The fourth thing about, yes, it's not going to happen overnight. From level zero, where only the humans will go and decide and change the lever of how you operate a vessel, to going to human is totally absent, you do it autonomous operations. Me strongly believe that we will not achieve five at all, maybe very few cases, but we will clearly go to the level of four, where humans will supervise, but systems will mostly in control. And humans still will have an eye, the way that we are saying that there are a set of people who are looking at what's happening centrally. And a lot of things are happening in the area of IoT and AI, because as I said, they are interconnected heavily when you apply in the industrial context. There are even a lot of ethical aspects. There are regulations are being formed, because if we don't properly leverage the IoT and AI in industrial space, it can create a significant damage. Right? So to conclude there, we said it has to be augmenting the human plus AI. I mean, we call it here human, which is one end we get the data from the IoT data that's coming to cloud, either using the edge aggregation or directly through the 5G, or it could be also through the different wireless edges, getting the data. And the data science teams, which advent of significant advancements, ability to not only depend on the first principle models and algorithms, but also get the value, get the insights through the data. Then we of course have the computing power and capabilities have drastically improved. Like the GPUs are ruling the world today for doing the deep learning. And as I was mentioning, you can't process with a simple CPUs. If you want to look at 9 petabytes of data, I mean, that will be needing hundreds and hundreds of cores of CPUs and terabytes of memory RAM. So you rather need to look at for even much better GPUs, and of course getting the AI that helps us. And as you can see here, while human is bringing positives on intuition, creativity, and expertise, whereas the AI is strong in expertise and computation. So this combination is what makes it work. And the way it will work on industrial AI is AI will produce the recommendations, and there will be a human loop that will ensure that the recommendations can be implemented by set of rules defined. Again, it will be software programmed, but the rules finally is also adjustable and managed by a human. The fifth thing that we talked about is when we go and implement industrial IoT, and we will have to look at on a business value, which is driven by a key process called as the value engineering. The digital industry value engineering looks at which of the value pillars is important for a specific industry or a specific customer, whether we need to improve the operations and detect the anomalies using the IoT and AI, or whether we need to improve the asset reliability and asset uptime, or whether we need to be looking at improving the sustainability by means of reducing the emissions, safety. You would have seen that for even the IoT application for the COVID sensing in the industry side of whether the people are wearing the safety equipments and masks and so on. You have the supply chain, which is extremely critical area today in terms of planning, because many companies are struggling. They are going to struggle in 2022 just because of the chips. When I talk about the IC chips, not our usual chips, eating chips, the IC chips manufacturing is limitations in companies such as Intel and Flextronics and so on. A lot of organizations are impacted even to deliver the projects. There's quite a bit of a blockchain and IoT enabled supply chain is needed. There's a huge area of currently research and innovation is going here, because necessity is the mother of invention all the times on business excellence. The sixth thing we briefly touched also is that it takes it takes a pretty solid approach and industrial process for how do we build a scalable IIoT solution for industry, starting from understanding the business objective, uh, creating a system blueprint, as I mentioned, the topology and needed in the industry context for deployments, for installation deployments, as well as running is very different in a typical lab infrastructure we do it. And then we need to look at how do we use the platform technology, APIs, components, and so on in a meaningful way. And then define the data management, define the how do you how much data that you would like to store it, what frequency you would like to get the data. Do we want to get on an event based from an IoT device or change detection basis? All kind of the decisions based on your use case and implementation will be done. Then finally, it needs to be built on a nice, good applications that the users will use it. So that's just also we saw that how we can build scalable IoT solutions. And I did briefly introduce about how we do that in ABB with an AIgenics, which mark as in every year in ABB's 130 years history, we have each year we call what is that the best innovation of the year. So 2020, as I mentioned, this was delivered, and this was delivered as the first digital product in the world, combination of IoT analytics and AI suite. And a pride for us is that it is majorly pretty much developed from India and Bangalore Innovation Center. So with that recap, let me go on giving the case study. As I mentioned, we look at, because we are fresh in the morning, I want to take also a few minutes for the people, especially you are in the software and the related fields, to understand, to unleash, just unblock what an IoT platform looks like. There will be some technical aspects I will be talking about it, but it's very important for you to know that also choose which is your area of interest to go for innovation. Then we go jump into, once you have this kind of a platform and solutions, how do you implement or how it is implemented in a typical customer environment and what's the benefits? Okay, so what you see here is a very simplified an industrial IoT and AI platform. And we will blow this IoT edge and integration in the next couple of slides, because people are typically interested also that how do I connect my IoT devices to the cloud? What is going on in that process? Here it is, one is what is going on by connecting the sensor data, IoT data, and systems data, enterprise social data, because when we work in the organization, we also have a social platforms within the enterprise, as you will have something within your campus. A lot of information is coming, unstructured data is coming from us. We have a Twitter just within the enterprise in ABB, same is in many organizations. They are only dedicated to the people that who are working within the organization. I mean, the working style of how we work in the industries have completely changed as well with the digital. Pretty much a similar Facebook is available just an enterprise level social within the organization, as an example. So we'll see what some of the key components that makes this whole thing work. I'll try to keep it as simple as possible, but if you have certain information is complex, you can always reach out to me for a little bit more details as needed. First thing, as we all know, that it's about data, and the data is coming from the different systems and different devices. Typically, we say that IoT is all about the sensors, but it is not the case in the industrial context. Sensors input is important, but you can't go and put sensors everywhere. Like for instance, when even in the social IoT, if I have to see the behavior of you all, how you are listening to this, I mean, I'm not putting sensors on you. I'm possibly looking at in terms of that how many people are attending, how many people are looking at, how many people are dropping, or how many people are possibly asking questions, and those kind of data, which is also called as a soft sensor data. So those soft sensor data comes in the industrial world from these systems, the operational systems, SCADA systems, PCS systems, engineering design systems, which defines how a digital twin representation can be built. And a lot of information from the ERP and systems such as the SAP, Oracle, which provides the maintenance activities, the planning activities, and so on. And the quality management system gives the quality data and so on. Now, this data is based on where they are generated. It can directly connect to the cloud of the IIoT, or it has to go through an edge. So edge here typically has the following components: software models. As we know, edge is a computer, a small computer. Nowadays, the edge is also becoming a lot more powerful computer, because you would like to do edge AI as well, not just only collecting data and pushing to the cloud, but you also want to compute, you also want to mine the data in the edge. So edge is nothing but bringing capabilities of the large data center cloud to closer to just your control systems or the plant systems. But these edges are having a hardware computer with specific hardened computer, but also having set of software models. Of course, first thing is you should be able to configure the edge to a specific cloud or specific connectivity. So you have a configurator, software, a messaging. So the edge collects the different signals from the underneath devices and systems, and it then translates into a standard messaging through a message broker. It then will be used for doing different, performing different actions in the edge itself, or it will be then pushed to the cloud. So you can do the computing on calculations. We have something called calculation engines in the edge that will do how do you calculate from the different data coming from temperature sensors, pressure gauge, and possibly from the camera input, video input, compute before it can be sent. The write back, meaning that sometimes you want to write it back. You want to possibly push the from the cloud. You want to bring the data back into the device as well. That's called as write back, and allows also different kind of the adapters, because in the world you have different kind of systems, different kind of devices. We saw yesterday that you have multiple different protocols to integrate. So there will be a way of how do you connect and make it abstract from there. Further on, there will be integration adapters. For instance, a standard adapter is MQTT adapter, OPC UA adapter, or it could be an SAP adapter if you want to talk to the SAP systems. The gateway proxy is clearly, as you would have studied in your an IT and networking, you obviously need to have a gateway proxy. It has a control for you to put policies, what is allowed inside, what is a read and what is a write, and so on. And you can also have a real-time dashboards. When we implement this in, as an example, yesterday, good question on oil and gas platforms, I mean, people on the sea. You will also see the edge. You will also have then and there to look at the real-time data on a dashboards. And it's not, edge is no more just a gateway of pushing the data. You store the data in a time series database, and you look at the data and analyze the data. So there is also a storage needed. So I would say that in last 5 years, the amount of innovations and the investments that R&D that we as an organization or many others like us is a lot on this. So we want to make the edge really rugged to be able to get a whole lot of data coming from the different devices and systems. Once you have the and you can see the dotted line, that line says that now we are getting into the cloud world. So far, this is predominantly in the plant or the platform, or in the oil and gas platform, or in the vessel. You saw that the cruise vessels, this will be installed there. But this one will be centralized. From this onwards, it will be a centralized, maybe a customer has their own cloud uh, for infrastructure cloud, or ABB is managing for them in our centralized cloud environment. Of course, we use the Microsoft Azure data centers, but we build all the technologies on top of that for the industrial IoT. So this will be interesting for if you really like the hardcore software engineering and software data structures, and if you love to write programming on different kind of data, this particular area is pretty interesting because here you will do a whole lot of stream processing, streaming data. That means that continuous stream of data. How do you process that? How do you take the meaning out of that? There's a big software program for streaming processing. A lot of open source technologies here that you would have possibly known, that Kafka and Apache's different Spark processing that helps on fundamental reference software, but a lot of additional capabilities needs to be added for the industrial IoT. Batch processing is that getting the batch of data, large chunk of historical data to bring it in. Then the unstructured data. I mean, we all know that the tons of data coming from the camera, videos, and the documents, the Twitters of the world, and the data which is totally unstructured, that data to be also brought in. And of course, the interface manager is to be able to connect to different edges, because we will talk now thousands of edges will be connected to this cloud. So you should be able to manage those edges. I talked about yesterday, how do you identify a device edge and certify it before it gets connected. All that happens in this. And I'm sure that in your curriculum you would have talked about data quality and data integrity is the most important thing for analytics. Otherwise, it's a garbage in, garbage out. You have missing data, you have anomaly, outlier data, and so on. You need to also map the data coming from this to this, this to this. All this need to be mapped. That is the heart of what we call as the system integrity. That means you are now developing from here onwards. It's no more about the IoT or sensor and whatnot. We collect all the data securely here and we map it so that now I know that I have a representation, I have a data and digital representation of my plant, my vessel, my different systems. So that happens here on what we call as a system twin integrity hub. In fact, my research area that I'm doing it PhD in the same institute with you is applying industrial AI in this specific block, which is the most complex area today in the industry, that how do you automate the mapping of the different data uh, through the patterns. You can't be keep on writing thousands of rules saying that if this is what you map it to this, that is going to be extremely complex, and people spend millions of dollars for that. Once the data is brought in, the whole data needs to be stored in large data clusters. We call this called as a cognitive data lake. Data lake is where you bring all the data unsaved, and it could be a raw store, just a raw data coming in. That is meaningful for us to bring it in. And you can imagine for this, you need to have pretty advanced technologies, at the same time cheaper storage. And any idea what will be a typical technology used for this kind of a storing large data in data lake? Anybody can possibly unmute and answer. Any guesses? What will be the technology for storing such a large data? You can't use RDBMS, right? You cannot use the database, standard database. You need to use something special. Anyone can answer? I'm not sure, Senthil, whether you unmuted anyone or they can answer, or if we can even read it from the chat, it will be good. Any answers? What what data technology will be used for this data lakes? Am I audible? Can you hear me?
Yes, sir. Yes, sir. You're audible, sir.
Okay, good.
Okay.
Okay, so I would have expected some of you could have answered this. That means that you need to certainly look at to get an understanding of different technologies. Hadoop is the technology used underneath, right, for storing very large amount of data to analyze it. You bring the data to Hadoop systems, Hadoop clusters of data. This data obviously will be able to store what you wanted immediately to use it, what will be used as a cold storage that you can bring it. And I always keep talking about domain knowledge in the industrial context, right? Industrial IoT. That is the piece here as well. You define the business processes of or operational processes in an industry, whether it is for the how the relationship between an asset in a hierarchy of a plant or with respect to an operation, all that business processes are defined as the data model in a highly normalized relational database management system, such as SAP, as SQL Server, or Oracle database, whatnot. That forms as the relational database. And the real-time data is coming and storing here as a time series database. It actually is storing, because your real-time data is always a time series, right? You can just imagine like a sine wave data or just a triangular wave real-time data that's stored in a highly effective time series database. So that's you must possibly would have used in your lab a time series database such as Influx. These are all open database. You should certainly explore them, understand them, because in the industry context we use that heavily. Of course, you will use the metadata, which are not real data, but information about the data. That is typically stored in a NoSQL database. You would have studied about different NoSQL database such as MongoDB and so on. So this layer is about how do you store the data and how do you model the data. So we first of all extracted the data securely from the devices. We then pushed in a secure manner through the IIoT technologies to bring it to the cloud. We qualified the data and mapped it to a structured data. We stored the data and we also apply the business process data models. Then it's all available for all kind of the use case implementation. Here, the model fabric is something that I would like to also quickly show you a demo that in a few minutes. That is where a data scientist and the domain expert and the data engineer work together to build the world-class artificial intelligence machine learning models. This was not possible if you don't have an IoT. This is not possible if you don't get the big data, right, to use it. Then you have also set of tools that is used for apps, analytics apps. If I say this, you might say that, oh, I'm studying programming languages because today you can develop many of these apps using no code platform. That means you don't need to code it. You can use it by drag and drop widgets. But if you are the ones who are going to build this platform itself, obviously you need to be best in programming. But if your aim is, I'm not interested in building a platform, I'm interested in building cool apps for users, then you better focus on how to a little bit of what user wants, as well as what kind of the applications are useful in the industry. You can build it using the no code platform. That means that you don't need to code much at all. This is your standard. You would have studied about the APIs for REST services to JSON services to be able to make it available for consuming all this IoT data as business services, and you can build all kind of applications. That's a typical way an end-to-end IoT platform looks. And I mentioned that I need your attention to also look at something that I want to show a bit technical, because it's important. You don't actually see completion of a case study of a platform. You don't get to some level of details underneath. So I'm going to take next 5 minutes as well for showing what major elements, and don't worry if you don't understand all of them, but just get a feel of it, right? This is just blowing up the components from what we saw in the last slide. For different systems, a different way connecting. People ask what protocols, what will be the security standards, and so on. First thing from the bottom up, you can see from the devices and systems, you have different protocols, standard protocols such as OPC standards or standard JDBC, ODBC for connecting to different systems and databases. You get that, right? You have the connect models or the bottommost layer on the edge, which is actually, as I said, edge is it's our architectural control point in the plant or in the vessel or in the platform rig in the sea for the oil and gas. You have the data coming in. You can use different technologies, Java technologies for connecting here, JDBC, or it could be .NET technologies. It's all the different flow. Don't worry about the data flow. It shows that how the data is going up and coming back and so on. I spoke about the message broker, the MQ series or any other open source MQ messaging queue broker that will have the data as well as share the image messages coming from different software components. I mentioned that if you need to store the data in the edge, you need to have a time series database for storing the data for a certain time so that you can analyze. You will also see some of them are coming as a file systems that will go directly to the file stores and a standard file protocol network to for it. Calculations are very important to do. You don't always deal with the raw data. If you're, let's say, for instance, you are getting the camera stream from the video, you're not going to just send that video stream as it is. You would possibly take, like you will snap it and derive certain things about information about it, then you will push it back. Because if you're pushing so much of data to the cloud, then it's no meaning. It's going to cost a lot. So there are set of components that are here to also process at the edge. You can also have some edge applications, as I talked about it. In the IIoT today, edge computing and edge apps is the most evolving area. Then the data is published from here to the cloud. And this connectivity, three things that you lines are coming, that's possibly the most complex in terms of the security that's needed, because you're now going from your own territory to the cloud territory. It could be a public cloud. So that needs to having a proper PKI certification mechanism, proper device identification mechanism, and then it should be also managed through the edge management portals that will be managing different edges. So this is an implementation in Genix. So here we call as Genix IIoT Hub. So it knows that how to identify, how to manage the edge, and how do you bring also the connectivity and data processing. Once the data comes to this, now we have the complete representation of all the different plant data or the vessel data, everything coming to this place called as an IIoT hub. And this IIoT hub is then routing it to different applications within the cloud side. One of the things we talked about earlier is the system between integrity for cleaning the data quality and aggregations, structuring the data. Then you can easily remember that we had a cognitive data lake where you have the raw data, and you have the RDBMS where you look at it on how do you structure the processes to make the sense of contextualizing this data for a business processes. And of course, then it goes for the different analytics and AI, and finally to the applications. So that's and of course that all needs to have a standard set of the authentication and authorization security, lifecycle management for the platform, alerts and notifications, mechanisms when things are not going above thresholds, and clearly the access control, who can do what and who should not be able to do what. And most important is that people now want a completely different experience even in the industries. Because even in the industries, manufacturing industries, it is not about only the people in 50 plus. We have people now with 20 plus as well, ages working. They want to get onto the company and just do a first, like a Google search. They want to do an enterprise Google search to see that, okay, what is going wrong? What should I focus today? How things are. So the platform needs to also provide enterprise search. So the thing that I'm possibly trying to also make you motivate you all is that, see, look, if you see my history, I started with Siemens, then Oracle, and worked on a whole lot of internet technologies to build it. Then eBay and PayPal, which is possibly the where you want to be the best place on security, payment, as well as the e-commerce online and search, enterprise search. I mean the online search. Then coming back to industries and SAP and ABB, because I felt that you will enjoy your domain knowledge you possibly developed in even your studies on electrical, electronics, and mechanical, and hardcore computer engineering. Plus, also you can work on the latest technologies such as the search, security, how do you build complex systems, how do you apply AI. All that can be done together when you come to the industrial IoT and industrial AI. Right? Some of your students or your seniors have joined in the companies, including ABB. You can suddenly get to see, ask them how do they feel, what they are learning. We will be definitely choose this as one of your paths for research as well as your career. Okay, going from here, I'll skip because this was going into just going into the details by the next level of details. In zooming into this, I spoke about it also, that data model. Some of you might be really having a flair on the database management systems and building data structures, complex data models. If that is your interest area, then you can leave some of your other friends to deal with how do you bring the IoT data, but then you can design the whole data lake to be with business process, and how do you store, how do you optimize. There's a whole lot of areas to focus on how do you manage the data once you bring the data, called the cognitive data. And today everybody says that I want to work on data science. That's because that's where you possibly see that predictions. Everybody wants to predict it. So here, as an example, with this, a whole lot of AML algorithms can be pre-built. Every whether it is ABB, Siemens, and everyone, they all have thousands of AML models developed for different use cases. And that's another area that you bring the knowledge of data, the knowledge of sensorization, as well as the IoT sensorization, as well as the data science together. In one of the very interesting areas today is about looking on how do you bring the vibration analytics, which was typically using the digital signal processing that you would have studied, but move from the digital signal processing to purely using machine learning and AI. Okay, so that's something is what constitute major elements of the industrial IoT platform and the AI suites. I mentioned yesterday about so important to have a IoT device onboarding process, which happens from the cloud. You store. You always have an idea about which edge and what it is, so that we know that to certify it. That's an extremely important process that is done using the edge management portals. I'm going to skip some of this. I always wanted to give a feel of how the software looks like. So you will be able to, using this management software remotely, can connect to a specific edge, configure it, deploy the software, deploy the patches, deploy the new models, and so on. They're all typically either Docker models or the Kubernetes clusters that will be deployed. And I did mention about they will have a standard convention of information, because you want to know about a device means you should have standard attributes. What's the device, what it contains, what information it provides, what is the metadata about it, what's actual data, and so on. You have a device information model. This is one of the key intellectual properties areas that for research. It uses heavily the OOPS concept you would have studied in your college. So I'm going to skip some of this, which is going to details. Then I will just directly jump on now on some sample customer deployment models. Just before getting into this, I'm trying to see if I can quickly show you also a demo of the product, for which I'm going to also invite one of my team member who's the owner of this specific model. Just give me a second. I will put on hold and reach him and come back in a second. Okay, so I'm back. In a second, we'll see Nitesh should be joining. Nitesh, once you join, just give give a quick voice so that we know that we are in. Okay, we'll know once Nitesh joins, but let me just in the meantime continue as well to save the time. Sandil, what do you once you see the Nitesh ready joins, let me know, huh? Then I will switch to the demos.
Yeah, sir. Okay, sir. I will inform, sir.
Okay. So let's when
Sir, he had joined, sir.
Okay, good. So Nitesh, can you hear us?
So a few seconds, sir. I will unmute his mic.
Okay.
I'm in the meeting, but unable to unmute. Few seconds.
Okay. So I'll possibly use the time continue it. So now we just talked about the what contains on the industrial IoT platform, the key components, which is important for you also to select the area of your research as well as the area where you could potentially build your career. Because there's not a single person called as an entire IoT engineer. There's a big organization for that. You have to focus on the areas that you would like to. I will show some three quick examples of the deployments, and we'll always talk about customer benefits, custom case studies in after the demo. Here as an example here, this is a large windmill renewable energy customer in UK and a lot of Europe, across the Europe. They have tons of windmills, each one of them, you can imagine that big generator, it has it. A lot of electrical transmission lines and equipments and switch gears are involved. So you have information that is coming from these assets, electrical equipments. And they follow some of the IEC protocols or the OPC protocols or Modbus protocols. They come here to the different systems, including
Excuse me, sir.
Yeah.
Sir?
Yeah.
Sir, now Nitesh Reddy is he's ready, sir. He can unmute his mic. He had I have changed his role as presenter. Okay,
very good. Nitesh, I will just in a few seconds, I will give you for the demo, right? Okay.
Sure, Rajesh.
So we went through in terms of the role of the edge in IoT platform side to collect the data and securely push here. So this is a deployment in which all this windmill electrical assets, the data is coming from the vibration system, from the data even coming from the drives and so on here, and it comes to the edge where you could do also the edge level application for monitoring the conditions. Then it's also going through a secure way from the what we call as the OT to IT to integrate it to the cloud. In this case, it's the Azure cloud of AIgenics in Germany. Right? That's we also saw some time back about what typically the components are there in the edge software here. Take another example where I always talked about how we using our collaborative operations in 21 centers, how we continuously monitor the plants and mains and the hoist as well as the vessels. So this is another example where the data is coming from the different assets and in fact they also go through the VPN link when it comes for we to make changes here on patches. That's again to the edge it comes to this platform across. Sometimes you will see also that multiple edges. In example here in a large pulp and paper customer. Here you have the devices sensors in the IoT device sensors. They also connect to the control systems as well as directly come to through the MQTT protocol that comes to the edges which are there. There'll be an edge which is there just on the plant, but in this case, customer also has another edge in the data centers or plant level data centers. We already saw that some of these tools what they are really meant for. And then through the protocol here, because we see here a lot of historical data as well to go. And we believe that it is important to use AMQP for optimized way of pushing the data as a protocol to go up. And you already saw that how this becomes as in the custom in the Genix components as an example, how the different typical industrial analytics components are installed here, deployed here to be able to get the value of data. Of course, we talked about these edges needs to be centrally managed and configured and security enabled in terms of certifying them. That happens through the management of the edges. That's just to give a feel of the how high level architecture of the deployments. So before going on to certain customer success stories, how it is deployed as a case study, we'll look at one component of the industrial IoT platform of Genix. So Nitesh, I will give the you can share it now, and what possibly you can do is that just to give when you go into give a flare of overall as well as just walk through on the model fabric in the next 10 minutes next.
Sure. So I hope my screen is visible.
Yes.
Okay. Yeah. So model fabric is a kind of a generic tool which will enable the business user or a data scientist to perform the typical data science related activities like the data exploration for exploring the data, visualizing the data set, and identifying what is present in the data and other aspects of it. And the model recommender enables the user to pre-process the data set, build models on the data with uh, regression models or the classification models, and register the models. So registry and deployment modules will be allowing the user to maintain the complete model lifecycle by controlling the versions of the models deployed, as well as enabling the user to deploy them onto production or archive the models from the production. And it also allows to add externally trained models onto the model fabric so that the life cycle can be managed. The model monitoring module here allows the models which monitors the models which are performing on the production. Like it will be looking at the data drift, the performance drift, and the latency drift of the model performance. So let me showcase the data exploration aspect. So when we load the data, we can load the data through the cognitive data lake, the industry cognitive model, or a local file upload. So let me select the cognitive data lake. So these are the containers, and we can select the files which we want to demonstrate. So let me select the mining data. So here in this data set, we have the timestamp. So user can filter the timestamp which he wants to select from the data, and he can continue. And once the data is extracted, we will be seeing the variable list. So this is the list of variables which is present in the data. Let me expand it. So these are the variables present in the data set and the data types. Let's continue. So here in the operating mode segmentation, user can give conditions based on which the data he wants to filter the data on. This is however optional. If he doesn't want to filter, he can go ahead. Let me give a condition where starch flow is greater than 0. And user can add sub condition as well based on a and or and multiple conditions as well. So depending on that, the data is filtered, and let's continue. So this is a preview of the data which based on the operating mode conditions and the variables. So this is the preview. Let me proceed. So this is the CDL mining data. I can choose to share the data with other users wherever I want to, and continue. So now here the data, we will be able to look at the statistical summary of the data in terms of the numeric, I mean numbers as well as on the plots. So here we can see the numerical descriptive stats on the different attributes of the data distribution, like the kurtosis, mean, absolute deviation for all the variables here, and also the quantized statistics for all the numerical variables present in the data set. We can see that, and the data visualization will allow user to look at the different plots for all the variables present in the data. So like this is a histogram for all the variables, and we have a host of plot options like the box plot, the violin plot, which will be showing the distribution in the violin plot format for all the numerical variables, and the line plot we have. So all these plots are interactive, where user can be looking into a particular section and see how the distribution is. And we have the correlation heat map, where we can visualize how different variables are correlated with each other. So even this is interactive, so that user can check a particular section of the data set. And we also have something called custom visualization, where user can create any number of plots based on the variables he wants to select. Like I want to create a scattered 3D plot. So I can select the X variable from the list of variables, the Y variable, the Z variable, and in case I want to have a color variable, I can select that. So let me select one of it, and I can generate the plot so that I can visualize from the perspective I want to look at the different variables present in the data set. So this plot is all interactive, and user can add multiple plots as well, and he can generate different plots with the available options and visualize the data accordingly. And these plots will be saved for future reference. The next section will be giving the user a summary of the missing and the outliers present in the dataset. So in this case, one of the variables called ore pulp density has missing of 19 rows. And we can also visualize the distribution, the trend, and the violin plot for a quick reference of this particular variable. The outlier summary gives the outliers present in the data for all the variables, and we have the computation based on the univariate IQR based and also the multivariate isolation forest based. So user can look at how the outliers are present for this data set. And yeah, so this is on the data explorer. So we have visualized the data. Now coming to the model recommender. So here user can create a new experiment where he wants to pre-process and build models on the data. So let me select the data which I just uploaded. So this is mining. Here we can see the preview of the data, and let me continue. I will be sharing this with the other users. And here we can see these are the variables present in the data. User can choose to keep the few variables or unselect the other variables which he doesn't want to keep as part of the experiment. And let us select the target variable. Here in this case, the target variable is the percentage iron concentrate, which I want to predict, given that the other variables are the process parameters. So one more key feature we have is the critical variable selection. So whatever is the critical variables or the control parameters which user wants to keep it as part of the model training process. So user can select that so that these variables will definitely be part of the model training. So I've selected these two variables, and we have two modes, which is the express mode and the advanced mode. So this is based on the persona of the users typically. So express mode is for the persona of a business user, typically who doesn't have the data science principles, but he wants to build a model on the data set. So this happens with the application defaults, which are stored in the app settings, which I'll be demonstrating shortly. So the entire data pre-processing and model building happens automatically with the app default settings configured as part of the application. In the advanced mode, we have the freedom for selecting the different treatment options of the data, different pre-processing options, and model building options. So let me go with the advanced mode here. So we are in the pre-processing phase. So as we remember, the ore pulp density had missing variables. So we can choose to treat with different options, which are shown here. So I can select maybe the median for treating this, and based on the selection, the plot here, the preview plot here is updated where the distribution is changed, and user can check the histogram trend plot and the violin plot with the different treatment options selected here, and accordingly he can take a decision like how what is the treatment he has to perform on this data set. Let me apply the 25th percentile. So the missing values are treated. Now coming to the outliers. For the outliers, we also have the treatment options of the mean, median, the flooring. We also can have a custom value which user can mention. We can delete the row or drop the column, and or we can ignore. So considering these are valid outliers, the default option we selected is the ignore. So let us ignore the outliers here. And moving on to the feature engineering. In the feature engineering, we have the zero variance identification. In this case, there are no zero variance features identified. And we have the multicollinearity identification for the target variable selected. So let me apply and check if there's a multicollinearity features. So these are the features. User can choose to remove these because these features, the flotation column 6 airflow and column 7 airflow are highly multicollinear. So we can choose to keep one of them. So I'll be choosing to keep this and save it. In the feature treatment, we have the feature selection and feature reduction treatment types. In the feature selection, we have the random forest, recursive feature elimination, backward feature elimination, and forward feature selection. With scaling options, we have different scalar options. Based on this, the feature selection happens, and the data is also scaled for the model building. And in the feature reduction techniques, we have the principal component analysis and the singular value decomposition. So in this case, let me select the feature reduction techniques where I'll be using the PCA with the min-max scalar. And let me apply this. So here we can see the variance versus the number of components plot. User can select the desired variance, and accordingly the components are selected here. And we can save this. I'll go with the 95% variance. So user can also download this data into his machine once this feature reduction is applied. And this data set can be used to train models within his system, or he can continue from here once the PCA is applied on the data set. So this can be done, and the data download option is given at all stages of the data treatment process. So this is the preview of the data set where it has all the components and the target variable here. Let me continue. Now we are into the model building phase. So let us configure the model building approach here. So for this target variable, we can choose the train test split ratio, whether we want the split to happen random sampling or sequential sampling. Let me apply this, and user can also download the train data and test data. So these are the host of algorithms we have, and user can select the algorithm which he wants to train the model on. He can select whether he wants to have a k-fold validation on the data, or he can disable this. We have the hyperparameter tuning timeout, where based on the Bayesian optimization, we try to tune the hyperparameters of the algorithms during the training process and within the timeout duration selected here. And the optimal hyperparameters are found out. So I will choose to train the models with this, and meanwhile the training process happens. So let me explain you the what is happening here. So here, once the train test split is done, based on this train test split, the hyperparameter tuning timeout, the models get trained, and the Bayesian optimization will be finding the optimal hyperparameters of the algorithms which are getting trained. and accordingly the final model gets built. So once the model training is completed, we can look at the metrics which will be showing us the train test accuracy of the model. Right. So meanwhile this goes on, let me come to the application settings, which I left off. So in the app settings, as I mentioned, in the express mode, we have the execution happening in the defaults. So all the defaults can be set here, where we have the missing treatment, outlier, feature engineering, model building options available, and all the defaults can be controlled from here, which happens in the express mode. So everywhere the options can be selected. So as we see that the model building is completed, let's come back to the uh, model building and look at the metrics where we left off. So here we can see that the models got trained. This is the testing metrics and the training metrics. And we can also look at the model plots where we have the actual versus predicted, the sensitivity, actual versus predicted plot between the train and test. The sensitivity plot for all the variables are shown here, like how sensitive it is to the input parameters, and the parity plot and the residual plots are shown for every algorithm which it trained on. The model summary here will be giving a summary of the features which are important and which will be what are the critical features that have gone into the model training process. And we have since we have gone with the PCA, we have the component level importances shown here for every component. This is the stacked bar chart where we can see the importance of every feature represented here and in every component here, right? So once user is satisfied with this model or the algorithm which is trained, he can register the model from here. So let me create a new model name. So my model name is mining iron concentrate. And yes, I've registered this with version 1 now. Let me move on to the model registry and deployment module now. So in the model registry and deployment, we have the trained model list from the model recommender. Here we were working on experiment 96 where we trained decision tree and XGBoost, and we registered the XGBoost with mining iron concentrate version 1. Let's go there. Now this model is registered but not yet deployed to production. User can click on deploy staging, change the staging status, select production and apply. And this model is now available on production. So we are utilizing a generic inference engine, which is exposed at this API, and all the models which are Onyx compatible, so which are open neural network exchange format. So we are converting all the typical TensorFlow models, the sklearn models, PyTorch and Keras models, all the typical machine learning, deep learning algorithms into the Onyx format, which is a independent platform format, and we have a generic inference engine for that. So this is a sample payload, and based on the model name and version, once we test the model, we can get the model prediction output here. And this can be this API can be integrated and be utilized in the downstream applications or the value applications where we want to trigger the model for the prediction. So user can also register multiple versions, multiple models here where there will be multiple versions, and user can manage the staging status here. So as I mentioned, user can also import an externally trained model. In this case, we have the Onyx and non-Onyx categories. Based on the ML framework, whether it is sklearn, Keras, TensorFlow, XGBoost or Onyx type, user can browse for the relevant files where we are asking the score.py and the model files. User can register the model and deploy it onto Model Fabric. So once the models are available on Model Fabric, we can also push them to an edge device where user can select the models here, select the edge devices, and then continue. Once we submit the task, this model will be pushed to the edge device selected. So right now there are no edge devices configured, so it is disabled. So let me move on to the model monitoring. So here we have a module called model monitoring, which, as I mentioned, will be looking into the performance of the models, and it will be detecting the drifts, the performance and the latency on the models. So let me show you one of the model where we have the reports generated. So this is one of the external model, which is R model. It is registered on model fabric, and the report, the data drift, the performance and the latency is generated. We can also look at the performance of the model by viewing the report. So here we can see for all the features. So this was a sample model using the iris dataset. So we can see all the features, and during the inferencing, this is the current distribution during the inferencing. So this was the reference distribution during the model training process. We can see how the data drift is on the data set when it is going to the model inferencing for every every variable which is going to the model. We can also see the target drift which is happening on the model, and we can see the target prediction by feature wise. So this detailing can be visualized here in the report. User can also download the report to his machine. And coming to the performance drift, since this is a categorical model, we can look at the categorical classification metrics, where we have the accuracy, precision, recall, and the F1 score, which is compared from the reference versus the current. Once the ground truth data is logged, we can see this report. We can see the class representations and the confusion matrix, the quality metrics by class for the reference versus the current, and also by the feature, we can visualize the performance of the model. So on a high level, we are seeing that there is, in this case, a 0% error detected and there is good performance. User can also download it and look at the report in detail. Coming to the latency monitoring, here we see how quickly the model is giving a response once the model is invoked and the inferencing API is called. So we can see the response time monitoring over time. So this is how it is. And we can see the distribution and the histograms of the response times. And this is a violin chart. So we can also see the response time month on month and week on week, so that we can get an idea of how the response time is progressing over time, whether it is good or bad. And accordingly, the infrastructure can be upscaled.
Nitesh, we can possibly wrap up with how this will be finally model is influenced.
Sure, Rajesh. Yeah. So yeah, all this monitoring is done, and user can also choose to retrain the model if the model is performance is bad. And essentially now these models can also be utilized to have the optimization done, where user wants to look at the optimal parameters of the inputs given a objective defined on the target. And also user can look at how the model is predicting over time with the given inputs. So these are different use cases which can be done. And yeah, I think that's all from my end. Anything else you want to add, Rajesh?
No, I think this is perfect. So you possibly can also the deployment study, right?
Yes.
Good. Thanks, Nitesh. This is obviously an industrial IoT course, and, which also clearly touches with the industry AI. And thanks, Nitesh, for coming in and giving a glimpse of how data once you bring it securely and how it is analyzed using the AI technologies for optimization, predictions and optimization. Yeah, you can possibly excuse me, Desh. Thanks a lot. I know you're a lot of work.
Thank you.
Okay.
Thank you.
Okay, good. Is that we have 2 seconds break is needed? I see a couple of people are on hold, or we can continue. Sanil, can we continue? Okay, I'm assuming that I take it as yes. Okay, let's get back from what you just saw is looking at how once you bring the data, how do you get the information for applying the data to use AI to build the machine learning models that will allow us to do prediction, that will allow us to also be able to do optimization, which is the fundamental purpose of also getting the data in IoT. Let me go back on quickly where we see some of this getting applied. Let me just hit here on the screen back. Okay, we talked about when we are deploying this IoT solutions to the customers. Ultimately, they need to bring the data to a cloud, and ABB as an organization can also help on analyzing the data and creating the predictions and optimization models, as I talked about here, using the collaboration centers, how we do this. Let me just give a glimpse of how that operating center works and how do they get data and act on it. There's a small video snippet. Hopefully it works. Let me just click this.
What is design thinking? At its simplest, it's a way of using a designer.
For thousands of years, mining has provided us with the raw materials we need to develop economies and build communities. This is as true today as it's always been. But mines are entering a new era. The environment of the modern miner is being transformed. Welcome to the ABB Digital Mine. In the digital mine, every operational detail is connected, improving safety, productivity, and efficiency. Mine location intelligence optimizes the potential for remote working. Real-time positioning insights and controls give miners 100% secure access control and shorter evacuation time. Monitoring and analysis services give you a real-time window into the most hard-working piece of kit on site, the hoist, detecting abnormal safety conditions early and avoiding production losses of up to 1,500 tons per hour. The gearless mill drive can be monitored anywhere, anytime. This means greater drive efficiency and availability, with reliability pushed to nearly 100%. Downtime is inevitable, but it can be dramatically reduced using insights taken from data analysis, mitigating and controlling one of the biggest and least predictable costs.
Hi, Sophia.
Hey, Mateo. The GMD is showing signs of wear. It's not urgent yet, but it's worth taking a look. I'm going to prepare some simulations for Nicolas. As soon as he's chosen the best one, I'll share it with you.
No problem. I'll get over there right now.
Okay, thanks.
Swift responses resolved remotely mean a lower cost per ton, and expensive assets need replacing less frequently. Intelligent scenario forecasting ensures that problems are resolved as efficiently and effectively as possible.
Nicolas, I need you to verify a repair scenario for the GMD before Mateo goes ahead.
Okay, I'll take a look.
Digitalization is having a major impact on all industries, and it has the potential to unlock huge value for mining companies.
Hi, Sophia. I'm at the GMP.
Hey, Mateo. I'm sharing the verified simulation with you now. Let me know how to get on.
Got it. I'll send you a full report as soon as I'm finished.
It's estimated that mine digitalization could save $373 billion by 2025, raising productivity, reducing waste, and keeping our mines safe. Welcome to the future of sustainable mining.
Yeah, hope you had a chance to look at
Bitcoin has made headlines over and over again because it has repeatedly hit.
Okay, but this possibly is what happens with the technologies of combining the industrial IoT in the context of the digital transformation. And this is just an example of how that's being used in ABB across to real-time monitor as well as the proactively predict the potential failures or modify the process operational elements to make it more efficient. Okay, so that's another example is I did mention about the autonomous truck. It is ABB's visual system, which has tons of thousands of sensors, IoT sensors on the vessel, that the data is brought through the satellite communication, and the data is brought back to our central collaborative operations center, the digital center, wherein it's being monitored to ensure that the different large assets are working, as well as also helping them to be able to give the dynamic routing, the fleet fuel efficiency systems, and so on. As you can see here, these sensors are all pretty advanced sensors. They also have a lot of virtual sensors of the data systems coming in here. And of course, an IoT platform as a suite that provides a way to get all this IoT data, but also getting the other unstructured data together to be able to use our analytics experts and the collaborative application technology support experts to be able to help the customers sitting pretty much remotely from here, because they are connected to a cloud-based system that's enabled by the industrial IoT. I'll give one more last example before we close, is where you will see the complexity of how you manage a highly scalable IoT edge system. Here, this is a customer who's the largest producer of stainless steel in Europe. Their goal is that, as I said in the beginning, industrial IoT is all about starting with the business objective. They want to minimize the breakdowns and maintenance shutdowns. They would like to avoid the quality defects of the steel produced. And they want to reduce the waiting time for both the raw material as well as spare parts in the production, which is the supply chain side. The solution here is using the industrial IoT platforms with AIgenics, which you can see in the right side that they have tons of systems and sensors from which the data is collected. For different lines, we need to identify this is for the unit, for instance, the unit in X city, this is a unit in Y city that needs to be brought in here. Then you have an intermediate way of segregating the information for them and keeping it secure for each of the mills. Information to not be used for the other ones. then it's brought to the cloud for bringing a specific set of use cases, right? Here they wanted, oh, we would like to know how do I predict the anomalies for the hydraulic systems? How do I avoid the mill bearing failure prediction, because that's keep on failing a lot of time. How do I ensure that my sheets, paper sheets are not breaking? Predict it, and so that you can adjust the parameters. So all those different applications or use cases are developed, implemented once you bring this industrial IoT platform, driving the data and bringing the access for us to apply the contextualized data. Right. This is where also, as I mentioned, always you bring the data, you don't just see to monitor, right? You don't want to just see the monitor. You would like to use it for prediction and optimization. That's where you combine also with the AI ML models along with that. I can keep going on multiple such use cases. One of the things that you might be looking at doing the research could be the digital twins. This will be my last piece to just give you an idea. If you see a typical refinery, let's take Reliance refinery or IOCL refineries and so on. You will see a very large process units, crude distillation. Then you'll have the sulfur recovery, the utilities and so on. There's tons of major equipments. 5,000 major equipments, assets, and 15,000 equipment. If one of them fails, then you have the whole plant can shut down, and it can also cause losses and damage. Right? You need to operate with pretty much 100% availability. So for that, the best way to replicate is to have a representation of the plant. In this case, the oil and gas upstream rig here, which is on a vessel on a sea. This what you see in the background is what is coming in the remote center of the digital center through the IoT sensor and the data coming to the edge, the cloud. It represents the digital twin, exact representation of how the plant looks like. It has the whole plant or the whole vessel here, digital twin. How the processes happens, the process digital twin, and individual assets, individual equipment, a compressor, generator, turbine. They're twin of them. Digital twin is nothing but you are simulating how physically it will operate, what are the different parameters we need to change it there, and how that can be simulated from a data and digital representation. It could be a 3D model or it need not be a 3D model to represent it. So an example here, I will, for a process digital twin to see that, okay, there is potential for this particular wall will be filing in next couple of hours. That is coming from the IoT platform analysis and the AI. So immediately the user can go and click and look at the system in which and identify which particular operation might be filing. Here it is talking about the compressor system, especially the chiller system in the compressor will just file, which can potentially cause the compressor to get heated, and ultimately there will be a potential loss and failure of the equipment as well as the operations. So it gives also the time remaining for us to act. So the maintenance engineer goes with the same digital software to look at quickly what should be and look at also the inventory available for the spare parts. Everything is available at one place to be able to go and execute it. That's like a way of providing both predicting, simulating, taking actions, everything just by looking at the digital representation of the same plant. Right? So that's giving you the feel of how the industrial IoT platforms and solutions are creating a huge impact for us in the industry 4.0. With that, I think it's a time for us to get on to any discussions, feedback from you, as well as any queries that you have it or questions you have it as well.
Thank you, sir. Participants, any queries? A few seconds, I'll allow the mic for them. Participants, if you have any queries, you can discuss it, sir. You can unmute your mic and you can ask, sir. Participants, any queries? You can also give in chat box. Participants? Sir, I think they don't have any queries, sir.
No problem. Thank you. I appreciate your time. Hope you found this sessions to be useful for you to both looking at it for your own learnings as well as your own research areas, but also deciding to plan your career where you would like to be. Thanks a lot again for the opportunity, and thanks Senthil for organizing this nicely. And
it's my pleasure.
We'll see you soon. I will obviously need to come to our institute. I also study there now in my doctorate.
Yes, sir. We'll meet soon, sir.
Thank you.
Sir, can we end the session, sir, now?
Yeah, yes.
No duty is more urgent than that of returning thanks. What cannot be learned through education, training, and observation is learned by experience, and learning through experience is hardest and the best. For experience is not inherited, but it is earned. With all his earned experience and knowledge, Mr. Rajesh gave a wonderful session with much real-time information and scope. On behalf of Computer Science Engineering, NIT Puducherry, I thank Mr. Rajesh Ramachandran sir for his valuable time to address the gathering with tremendous information. I also thank Mr. Nitish to volunteering his time to provide the demo to our participants. Thank you so much, sir.
Thank you. Thanks, everyone.
Thank you, sir. Participants, the next session will be commenced by 11:30. And for your kind information, the assessment that consists of 30 MCQ with some basic questions will be conducted from 2:30 to 3:15 p.m. And feedback link will be shared at the end of the second session. Thank you for your time. We'll meet after that break.